This morning, what we will do is to work on classification of living species. The activity is divided into two parts. The first part is focusing on geometrical forms in order for the participants to learn a methodology of how to classify living species and what's the difference between classification, sorting, etc. And the second part of the activity will be to apply this methodology to living species. We will introduce some species, we will discuss the characters and how we can make groups of species sharing the same characteristics and how we can define species, families, orders, etc. We will work with geometrical objects like this one, just to speak a little bit about the methodology. And after that, we will apply this methodology to living species. Okay? So don't be surprised if there is no living species here. We will speak about living species. Henri and me will distribute you an envelope which contains some objects. And first of all, I would like you to observe the objects and to describe them. We will do that all together in the whole group, okay? Oh, please take care of all these little objects because it took me hours to cut, and so literally several hours to do that. So I would like to get them back at the end of the session. And one here for Swansea if you want. So we are listening to you. So just for the moment, observe and describe what kind of objects you have. Oh, sorry, I forgot to precise something. When you speak to the whole group, speak loud because there is a camera. We have to listen to you clearly and so on. So speak loud. So you have different shapes. Yes, what kind of shapes? Circle, triangle, square. Okay, so different shapes. What else? Colors. What kind of colors?
Purple, blue.
Yeah.
Yellow.
Okay. Different, yeah. Okay, so shapes, colors, patterns. What kind of patterns do you observe? Lines, plane. What's so? Solid. Okay, so we have a lot of different words to describe these objects, these forms, and these different words we use is linked to the diversity of the objects. Now I will ask you a very simple task. That is written here. Please put some order into this mess. Some of you have already put some order because you are an organized person and you don't like. Sorry? Yeah, you're completely free on. You're completely free on how to put order. Okay? Just decide a way to do that, and after that, you describe it to me. Could you please describe me how you organized all these forms.
We have 1, 2, 4 shapes, and then we classify into the colors, and then the pattern inside the texture.
Okay. Maybe I will. We took photos, but so basically it looks like that. Okay. Some of you made different organizations. Could you please reproduce explain and reproduce it on the ground in order to everybody be able to see it? You put it on the ground and you speak. Because everybody is waiting for you. This one was a bit different of the previous one. Can you explain? But for you to explain, we have to obtain silence in the room. So most of the groups have basically do the same, except your. This is why I would like you to reproduce exactly what you have done before, and not to be to imitate what you see on the floor. So, can you describe what you have done?
We're using a binary system for classification here. Okay, the first stage is dividing all this thing into 2 groups, which is the one with the sides and the one with no sides. Okay? No sides means circular. Yeah. So the one with the sides, we divide it into 3 sides, which is the triangle, and the 4-sided, which are the squares and the rhombus. Okay? And for this side, we got the side that is the circular shapes. We divided it into 2 first, which has lines on it. The stripes on it, and the other one with the checkered pattern on it. Right? So after that, we divide it into colors, different colors. That's all.
Okay, thank you. Yes.
For this one, we can say, is it a cell? We start with the first. Is it a cell?
Okay.
Then, if yes, so we put it to the side. No. Then from here, we can say, is it a square? Then this one is a square, and this one is a good side. There are squares. And then we separate it like, does it as straight lines? The circle does it as straight lines? Then that's why we separate this. Plus this one, they have straight line, and this one, they have brick or.
Okay.
Then after that, we'll separate them into different colors. These have straight lines. Is it blue? Is it green?
Okay. So, in a few minutes, we will go further into this classification, and you will draw samples like this one, or imbricated samples, or trees, or whatsoever. Just be conscious that I didn't ask you to classify objects. What was the question?
Order.
In order.
Order. And there are a lot of different ways to order. And classification is one of the possible ways to do that. And we will discuss on the different ways. So can you identify the different ways we can use to put order in such a mess? Plasticine and pen. because so try to build an embedded classification. You can start.
Fertilize, and then you get the jet generation. So this one two items make, you get same characteristic 1, 2, 3. We don't know whether it's correct or not. So these 3 characteristics. Yeah. Okay. So when this square.
En fait, il raconte une histoire, mais cette histoire n'a aucune logique.
They've got 3 children, 3 items more, bring 1, 2, 3. But this one is carried by all companies.
Okay.
The same thing happened here. All companies.
Okay. So, can you comment this classification? J'espère que non. So, do you have comments?
I think this is more like a family tree. This one marry this one.
Okay. Okay. Please look at this picture here. I said, okay, this is a family tree, and thanks to the archive, the only living persons are here. All these people are dead, but thanks to the archives, we are able to reconstruct the history. We know that their parents was this woman, this man, etc., etc. But for living species, we don't have the archives. The only thing we have is living species, living now. So all our species are on the same level, this level. We don't put one up and say it's here, and this one is here. No, everybody here is at the end of the history. The species living now, today, not ancestors. Okay? So here you have construct an history, but it's not a classification because this species didn't exist at this time. This is supposed to be time. Okay? This species only exists here. All the species are here. So now you will have to try to know which is the closer to, which form is closer to the other form and farthest to another one. So this form here in your history, they are brothers or sisters. But I cannot see that they share the same characteristics. In fact, they are the most far we can imagine. They don't have the same shape, they don't have the same color, they don't have the same pattern. We cannot imagine that they are brothers and sisters. It's impossible. They are too different. It's as they have let's say, legs and plumes, or a vertebra, and etc. They are so different that it's impossible that they are brothers and sisters. They can't have the same parents. It's impossible. So the exercise what not to imagine a possible story, but with all what we have today is that, and just what we know is that is today. And imagine who were their ancestors, etc., etc. So we will examine what have been done in the other group. Individual is a living individual you have observed in nature, for example. So they are all living today. So please, someone who will describe?
So we have two characteristics that we sort of classify the lines and stable. So we have, but then line, we have two types, one with 4 lines and one. So under 4 lines we have a diamond.
Diamond and square. Oh, okay.
The other one, circles, we have circles with straight lines inside, and another circle with check boxes inside.
Mm-hmm.
But then they have different colors.
So if we want to reconstruct the history of evolution, we can say, okay, these species share the same characteristic. They are 4 lines, so they are close together. They are in the same box. And they are closer together than they are to this one, for example. They share more common characteristics. This one shares more characteristics with this one than with this one. So it's normal that they are in the same box. Okay? And after that, the other species which they share the most characteristics are those one because they have lines and not this one, etc., etc. Okay, so this is a classification. I just have a remark that there is a confusion between the name of the box and the name of the characteristic. For example, here you have written your character. I mean, they have lines, they have circles. Yeah, a circle is also a line, but it's just a problem of straight lines, etc. Okay.
Straight lines.
Yeah, okay, no problem. But here, this is the name of your character. And here, this is not the name of the character. Diamond is not a character. Here, you have given a name to the species. And here, the name of the character. So maybe if you just want to put characters on this, what could we have?
So these are the species and this is the color.
So if we just want to write characters and not species name, what is the name of the character here and here? What's the difference?
Something like the angles or something.
Yeah, here we have 90 degrees angles, and here we have less than 90 degree angles or something like that. Okay, okay. Everybody, here, all the lines have the same
They're all the
length,
same size.
same size, and here not.
Are they not?
They don't have
No.
this one.
If you have a parallelogram with all the lines with the same length, it's a square. Otherwise,
The sides
you
are-
have this one is equal to this one is equal to this one, but here they are not equal. Otherwise, if everything is equal, it's a square. Okay? So here you should have written, let's say, same length and different lengths, or 90 degrees angles and something else. What's it? Okay.
If we take a square means must have 90-degree angle.
But we're giving it a name.
Yeah, but this is not the name of your character. This is the name of your object. Yeah, your character is the presence of a 90-degree angle. If this character is present, then the name of your species is square. Okay? So here, this is the name of the character, not the name of the species. Okay? Here, it's not the name of the species, blue. We can imagine that we have a square blue. So blue is not the name of the species, it's the name of the character.
name of the species will be a square. But characteristic, 90 degree angle.
Exactly. So maybe we can write everything on the classification. We can, as we have different colors, we can say, let's say, for example, we will write characters in blue and the name of the species in green or whatsoever. We can write the different things. Okay. Here we didn't find. Imagine you discover an ancestor, a skeleton, or something like that. You will find this ancestor. You will give him a name. But up to now, we don't have discovery. So we just have the name of the character, checkbox. Not the name of the species, because we don't know if this species. We think this species has existed before, because it will be logical. But we didn't discover it yet. Okay. So, yeah.
I just got one question. Before I was doing it, I was thinking of doing something like this.
Yeah, I remember.
Why can't I do something like this? Like, all the other ones here, doesn't matter. All the four sides here. I mean, this is a triangle.
What's, please give names to your box, and we will.
I see.
What is the name of this box? Circles?
Circles,
What is the name of this box?
lines.
So
Circular
why?
lines and.
So why is this one inside the lines?
Because
This is the problem. Remember, this is why when I saw that in your drawing, I said, okay, if you represent it not that way but in a tree, it's similar as to have one species belonging to two different branches. It's impossible. You have one ancestor, not two. Okay, so you have to make a choice. This one is here or here, but not both. Here you don't have several ancestors for one species. You have one ancestor. Okay? Can we examine, look at what have been done here?
Okay, we can start from the bottom or from the there. Actually, this is our object. So we have all the objects. We divide into two-sided and curved. And then at the sided, we have the four side and then three side. And then at the four side, we divide it into angle of 90 degrees, and that's not 90 degrees and not 90 degrees. And this side, we have the circle with the texture check, and this one is with line check. And then we divide it into two. This is the color, the same shade, and then the mirror shade, the tone mirror,
yeah.
blue,
Okay.
and then this is brown, but this one is the opposite one.
Okay, so here there is another step in the classification, is the tone. But basically, the beginning was the same as we have seen before. Same remark as I have done. Imagine that this is a specific species. Let's say it's a dog. Let's say this dark blue with lines is dogs, and light blue is cats, let's say, for example. So their ancestor is not a dog and a cat. This is the species living now. So they have a common ancestor, but it's not this. This is a dog. The ancestor is not a dog. They have one ancestor, which has characteristic lines, but we don't know. This is not this individual. Okay, it's the same here, etc. All the species are here because they are living species that we can see today. Okay, you don't know the ancestors. You just know their characteristics, but you don't have individuals. Okay, this is the only remark. Okay, did we see all the productions, or did we miss one? Yeah, we missed one.
Here we like three sheep. Okay, so we divide it into two. One is this one is without angle, and this one
Angle.
this
This is
angle
angle.
is without angle. No angle. So this one we have like diamond
The
box.
shape.
Four angles.
Three angle. Four angle. Three angle. And this one is the color. This color we have line. Color with line and color with dot. So we divide like
Okay, comments? Is it similar or different of what have been done before? Similar. The representation is quite different because it's a tree, but basically it's the same idea. Okay, thank you. Now I will give you new spaces. Imagine you have made an exploratory mission in Indonesia or in wherever, and you discover a new space. So where do you put it in your classification? And now we know that doing a classification means to put together spaces that we suppose they are closed in the history of evolution. Okay? So at the very beginning, all of you have made the same classification, and you have chosen to privilege to put the stress on the shape as a first classification. So we can imagine having different samples. The black box is geometrical forms. Here we have forms with lines, forms with circles, etc., etc. It's another way to represent your classification. Okay? Circles with blue stripes, fuchsia squared cycles. So this is circles with stripes, squared circles. Everything here is circles. And here, if we want to generalize on living species, we could say that this is a species. The other box is a genus. And here we have a family of circles. We can see the parallel with the classification of Linné. Linné is very famous because he introduced not only a methodology to classify, but also a vocabulary, which is still in use today. Today, we don't classify the same way as Linné did, but we use the same words. So species, genus, family, order, class, etc., etc., etc. And what happens if you discover a new species? But just first of all, we can see even today this vocabulary when we give a scientific name to one species. Basically, one scientific name is always composed by two names written in Latin. The first name is the name of the genus, and the second name is the name of the species. Okay? Here we have 4 birds, Parus major, Parus minor. So 2 different species, but they are in the same genus, the genus Parus. And after that, 2 different species, but in the same genus Cyanist. Family Paridae. Okay, so when we do a classification, we always have to name, and this is called in science the systematics. So here, our systematic was circles, etc., etc. So what happened when we introduce a new species like this one? If we remark that there is just the color which is different, we just have to put one box here with black lines. But if we remark that there is also the shape that is different here because the lines are wide apart and here they are closed, then we have to introduce another box. And the more species you discover, the more complex your classification tend to be. So in reality, when biologists classify species, they have to introduce a new kind of boxes. And so now we just add different intermediate boxes inside the linear classification. So between the species and genus, we introduced series in sections. Between genus and family, we introduced tribes, etc., etc., etc. Yeah.
They say the three box of the black, the stripes is black and red. Inside the circle. Where is the other before?
Stripes, black and gray.
Black
Two
and
stripes.
red.
That's
Two
it, yeah.
types
Have
of
two
colors.
stripes.
Here, black and gray.
Yeah. Now it's only
Inside the circle.
inside. Now it's only one color. Let's see if you have
Ah,
black and red stripes.
yeah, okay, okay. You should say this is black and this is color. This is your question?
No.
No.
The stripes have two colors. Black.
The stripe has
Yeah.
the circle have two types of striped colors. Mean black and red.
That one.
No, I don't understand. I'm sorry. Show me. T'as compris toi? Bon. Yeah.
Black and red.
No, it's
Where put it?
Where you put it?
Black.
okay. This is a problem with the printer. They are supposed to be the lines are supposed to be the same inside one circle. Yeah.
Let's see.
Okay. Sorry. Then you have to imagine a new classification with a new box, with monochrome lines and more than one color lines, etc., etc. You have to introduce new boxes. And in fact, this is what happened when we introduced this new species here. Because we can say, okay, it's a square. We have to put it here. We have to divide this box into two parts, plain squares and pattern square, or yellow and red, for example. But we can also say, okay, this is red and this is patterned, so we can completely change our classification and say, okay, instead of starting by dividing by shapes, we could start by dividing by pattern and say, okay, all the pattern one side, all the plane on the other side, etc., etc. And in fact, there is no correct and wrong answer here. It depends on all the other characteristics. For example, this is similar to what happened. Imagine you know two species, one mouse and one bird. Ah oui, merci. Prevents accident. you know two species, one mouse, one bird. And you discover a new species, the bat. So where to put the bat? Is the bat close to the bird because he has wings? Or is the bat close to the mouse because he has hairs? You can't decide. It's a choice you have to make. And when you are confronted to such a choice, you have to examine all of the other characteristics. Just this new characteristic is not enough to justify one choice. But thanks to the other characteristics, you will say, OK, the bat has more common characteristics with the mouse. It's a mammal, etc., etc. So I will put it closer to the mouse than to the bird. OK. This is something that you should do after this activity. So I won't go into detail because you have to produce it. But unfortunately, we don't have time to do that in the morning. We just have 10 minutes left, and it's not enough. We need approximately 1 hour to do that. So the next step is to, OK, now that we have defined a methodology for the classification, we will apply it to real spaces. So I will give to you different spaces here. The work we have to do is to identify first what are the characters that will help us in our classification. Here we had colors, shapes, and patterns. Here we will have to identify the characters and then examine how we can use this character to build a classification. And the result of this classification, there is only one classification possible here. This is this one, and I don't show you anymore. OK, so because you will do it. You will not do it now because I'm afraid we will not have time. But it's not a problem. We just need 1 hour. And so it will be easy to find 1 hour during the week. So maybe tomorrow, maybe after tomorrow. It's not a bad situation because you will have time to digest what we have done this morning and to apply it after.
I'm Juria Abu Bakar from IPT Campus Pulau Pinang. Okay, I came here. This session for me is very good because we start with something simple for the student. Okay, like first thing we have to sort out, and then we have to do the criteria, and then we do the classification. Okay, normally in our school we just start with the classification without identifying the stages of this. Okay, so for me it's very important, and then it's very good for us the exposure of this session.
I am very glad to have an opportunity to participate this morning session on classification of living species. Really, it's amazing to me that with a very simple thing, we learned a lot with hands-on activity, how we can teach our students or teachers how to deliver the session on living things. Really, in my country, in my experience, really this session, our teachers deliver their classes with their book, especially rote learning. But this activity will help us to teach our teachers how they can deliver their classes, especially on this session with hands-on activity, with using simple material.